This video is about inverse variation. Inverse variation as nth power. Let n be a positive real number. Then y varies inversely as the nth power of x, or y is inversely proportional to the nth power of x. If for all x there exists a non-zero real number k, that k is called the constant of variation, such that y is equal to k over x to the n. If n equals 1, then y equals k over x. So when we did direct variation, you would set your equation as y equals k times x. So you're multiplying. But if it's inverse variation, you're going to divide. So we're going to follow the same pattern here, except we're going to set up our rule differently using the division. If y varies inversely as x, so that's going to kind of give us an idea how we're going to set this up. Y is equal to k over x. So it says y equals 20 when x is 1/4. So 20 equals k over 1/4. So to solve for k, I'm going to cross multiply here. 1/4 times 20, k would actually equal 5. Taking that back up, so my rule for this problem is y is equal to 5 over x. So find y when x equals 15. So y is equal to 5 over 15. That reduces to 1/3. Let's look at a real-life application of inverse variation. The weight of an object varies inversely as the square of the distance between the object and the center of the Earth. Well, if you have the planet Earth here, from the center to the surface is about 6,400 kilometers. So I need to give you that information for you to be able to work this problem. If a man weighs 90 kilograms on the surface of the Earth, how much would he weigh 800 kilometers above the surface? So let's talk about the first sentence. The weight of an object varies inversely. So k over the square of the distance between the object and the center of the Earth. So a man weighs 90 kilometers on the surface of the Earth. That said, his weight is 90. If you're on the surface of the Earth, the distance from the center to the surface is 6,400 kilometers, and we're going to square that. So it's the square of the distance. So k in this problem, if I multiply 90 times 6,400 squared, that's going to be my constant of variation. Now you can multiply all this out and get a big number if you want to, but I believe I'm just going to leave it the way it is, and maybe use it to, maybe it'll reduce when I work my problem. So the weight is equal to 90 times 6,400 squared over the distance squared. That's how we're going to set up our equation. So how much would he weigh 800 kilometers above the surface? So the weight would equal 90 times 6,400 squared over the distance. In this case, if we went 800 kilometers above the surface, you would add 6,400 plus 800 above the surface of the Earth. So plus 800, which is 7,200. So we need to reduce this fraction, either reduce this fraction, or we could possibly use our calculator to do all the number crunching. I'm going to say 90 times 6,400 squared. I see some reducing that I can do here. 7,200 squared. I can reduce 90 would go into 7,200. 80 times. That's going to reduce more. I like reducing this fraction. So that's 6,400 times 6,400 over 80 times 7,200. The 80 goes into 6,400 80 times. I know that 6,400 and 7,200 would both reduce by 100. So let's see if we got to reduce any more. I've got 80 times 64 over 72, and I could reduce by 8. So 640 over 9 is as reduced as we can get on that. So that's approximately, if you wanted to just divide it out, 640 divided by 9, 71.1 kilograms.